Okay, so now let's say you have been given a number num, okay, and you are supposed to find the square root of that number num. So guys, you might remember while we were studying maths, we were studying prime numbers and factorizations. So we had to iterate from 0 or from 1 or from 2 till square root of n. For that you needed to find sqrt of number, right? So have you all used this function at least one time in your code, sqrt, whether you code in Java or C++ or Python or whatsoever. Now is the time that I want you to implement this function. So just implement this function sqrt of a number num, which gives me the square root of a number. Now you should implement it in a way that if the number is perfect square, in that case, if let's say you are giving this, it should output 6. But if the number is not perfect square, if let's say you have something like this, 50, then your output should basically be the floor of this thing. Okay, what will be the floor of square root of this? It will be 7, right? Because the square root of 50 is 7 point something and the floor of this will be 7. So this is what the question says. If the number is perfect square, return me that perfect square root of it, and if it is not perfect square, then simply return me the integral part of its square root, which can be gotten from the floor of it. Can somebody tell me what will be the output for num equals to 97? It will be 9, because the square root of this will be 9 point something and its integral part will be 9, correct? So think, how can I implement it? Think of the different ways to implement it. Yeah, so a very easy approach will be to write a for loop, and you can iterate that for loop till some point. Yeah, so what you can do is you can write a code where now can square root of any number ever be negative? Can square root ever be negative? No. So the square root will at least be 0. So it is a very wise choice to start from 0. And till where would you want to go? Can I write a condition like this? As long as I into I is smaller than equals to n. Can I write it like that? I can, right? And once you have written this condition, then your job becomes very easy. Then what you can do is that if you see at any point of time that I into I is, I think you don't need to even write it, because you have initialized I equals to 0, and now if let's say there is any value of I for which I into I has become equal to n, the loop would be broken. The loop would be broken, and for a number like 36, your output would be 6. For any number like 50, what would happen? That for I equals to 7, you will see that 7 into 7 is smaller than equals to this. So it will move on to 8. And for 8, the loop would break. So you should have a check. For whatever value of I the loop got broken, you should check if I into I is greater than the number num, then your answer should be I minus 1, because I am interested in the floor value. And if it is exactly equal to the number n, then your answer should be I itself, right? So I think that is very simple to think of. What is the time complexity of this approach? This is order of square root of n. No, why order of n? This is order of square root of n, because your code has started from 0 and it has gone until square root of n. But is there a way to do it better? Can I do something better? So the answer is yes, I can do something better. So guys, see, if you try to understand, technically this question says that it wants you to find an I, such that I into I must be smaller than or equals to n, and I plus I into I plus I must be greater than, strictly greater than n. This is what you are trying to find, right? Such that I into I is smaller than equals to n, and I plus I into I plus I is greater than n. That I will be the square root of the number num. You can just think it, guys. I think this is very easy to understand, right? If let's say you had 50, okay, for 50 you got 7. Why 7? Because 7 into 7 is 49, which is smaller than or equal to 50. But 8 into 8, which is 64, is definitely greater than 50. So in this case your answer should be 7. Okay, so this is what I technically want to find. Now just think of it in this way, that can binary search be helpful? If yes, then how? So if you take a look, this value that you are seeing, f of I is equals to I square. How does the graph of this function look like? If I create a graph of y equals to fx, where fx is x square, how is the graph going to look like? This is going to be a parabola, right? Correct. And that particular parabola will be having its vertex at 0. Now this entire function, is this entire function a monotonic function? No, this is not a monotonic function, because in certain part it is decreasing and in certain part it is increasing, right? But the thing to understand over here is, I said that my answer will definitely be greater than or equals to 0. Since my answer will definitely be greater than or equals to 0, the value of I that I will consider to act as the square root of a number num will definitely lie in this part. So can I safely ignore this part of the curve? Yes, no, can I do that? Right? So can I say that in this domain, which is the domain of my interest, or the search space of my interest from 0 till some point, this function is definitely monotonically increasing? Can I say that? So in this part, the function is definitely increasing monotonically. Now if it is increasing monotonically, then basically I am interested in finding a value I such that the value of f of I, which is I square, is definitely smaller than equals to a number num, and the value I plus 1 corresponding to this whatsoever is the value, that is definitely greater than n. So can you find this using binary search? So now again, before applying binary search, there are two things which are important. First thing, that the function on which you are doing a search, that should be monotonically increasing. Monotonically increasing in what range? In the range of your interest, which is your search space. So can you tell me what should be my search space? Whatever will be the answer of this question for this input, in what range will it lie? From 0 till where? Is it safe to say till n by 2? Guys, think and then answer. Is it safe to say till n by 2? Because if let's say this number num was 1, and if you are considering a range from 0 to num by 2, your range would have been 0 to 0. But the square root of this is 1, and does 1 fall within this range from 0 to 0? No, right? So what is the safest range that I can have? The safest range that I can have is from 0 to num. So whatever will be the square root of a number num, that will lie in between 0 to num, right? So this is what you can do. You can say that answer will definitely lie in between 0 to num, and if you know that, then your job is very easy, because now from in between 0 to num, you are trying to perform a binary search. So what do you do exactly? Think of it in this way, that this is what your square root is. This is what your answer is. For a moment, think of it like that, I. Okay. Now, for all the values that are greater than I, let's say you consider any value j, what will you see? F of j, it will be j square. Can I say this will definitely be greater than num? I'm saying let's assume that I is the square root of the number. So if you take any value that is greater than I, f of j, where j is greater than I, will definitely be greater than the number, because j square will be greater than it. So all that I am saying is, you can initialize your lower search space to 0, lower bound to 0, and high one to num, and then you can figure out a mid. Once you have a mid, you can check for the value mid into mid. Okay, if this thing is greater than num, if this thing is greater than num, can mid be my answer? Can mid be my answer? No, mid cannot be my answer. Can answer lie to the right of mid? No, because this function is monotonically increasing. So if mid square is greater than num, mid plus 1 whole square will be even greater. So in this case my answer is towards the left side, and when the answer is towards the left side, what do you change? Do you change your low? Do you change your high? What do you change? You change your high. So whenever this thing becomes true, you have to do high equals to mid minus 1. Okay, otherwise what should you do? Otherwise it means that your mid into mid, it can either be smaller than or equals to num. Okay, so in this case, will you always move to the right? Will you always move to the right? No. Why? Because you are not sure if you are at the answer. And how can you detect if you are at the answer or not? Remember the arrays thing? You have to check for the just higher value. So you have to just check for the value of mid plus 1 into mid plus 1. So you have to check for this thing. Else, if you see that this particular thing is greater than num, okay, if this particular thing is greater than num, then can you say that mid itself is your answer? You can say it, right? So if this condition is true, you can immediately return mid. But if this condition is not true, it means that mid plus 1 whole square is also a value which is smaller than or equals to num. So what will you do in that case? What will you do in that case? You will move to the right side, because in that case your answer lies towards the right. So in such a case, when this condition is not true, then you would move to low equals to m plus 1. Let us take an example. You were, let's say, trying to find square root for the number 50, and let's say at any point of time your mid was equal to 6. So if mid was equal to 6, will this condition, let's say this is if, will this if condition be true or will this else condition be true? Else condition will be true, because 6 square is 36 and 36 is smaller than the number. Now to check whether the 6 itself is the answer or not, you will check what is the value of 7 square. Here you will see that 7 square is 49, and that 49 is not greater than the number. Okay, so you will move to the else part and you will change low equals to mid plus 1, and now your low will become 7. And now let's say somehow your mid again became 7, then again you will come to this else case. Now for this 7, when you check 8 square will definitely be greater than num. So if 8 square is greater than num and 7 square is smaller than or equal to num, 7 is what I want. So I should be returning the value which is 7. What will be the time complexity of this? What is the number of steps of binary search in general? Number of steps is also log of the size of range, and the size of range is high minus low, which in this case is num. And in every iteration you are just doing order 1 work of comparisons. Okay, so this will just be log of n. Okay, so to write the code you can have low equals to this, high equals to this. Now while you see that low is smaller than equals to high, you can get your mid, which is low plus high upon 2. Now you will check if mid square is greater than n, what to do? If mid square is greater than n, that means I am towards the right side of my answer. If I am in the right side of my answer, I need to go to the left. For that I need to do high equals to mid minus 1. Else what should I do? Else it means either I am at the answer or I am to the left side of my answer. And how do I check that? To check that I need to find out m plus 1 square. So here if m plus 1 square, if this thing happens to be greater than n, then it guarantees that m will be my answer. Otherwise my answer will definitely be to the right side of m. So for that I will do low equals to m plus 1.